In example 11, we want to be able to calculate continuous growth or decay formula. The continuous growth decay formula is the following. For all real numbers t and all positive numbers a and r, the continuous is the key word here. Growth or decay is represented by the formula a of t, which is equal to a with a base of e and an exponent of r times t. So a is the initial value, r is the continuous growth rate per unit time, and t is the elapsed time. Now, if the value of r is greater than 0, then the formula is going to represent a continuous growth. If r is less than 0, then the formula is going to represent a continuous decay. For business applications, the continuous growth formula is called the continuous compounding formula, and it takes the form a of t, which is equal to p e to the rt, where p is the principal or the initial invested, r is the growth or the interest rate per unit time, and t is the period or term of the investment. So for example 11, how do we go about calculating the continuous growth? Well, given the initial value, rate of growth or decay, and time t, we're going to solve a continuous growth or decay function. Step 1, we're going to use the information in the problem to determine the value of a, which is the initial value of the function. Step 2, we're going to use the information in the problem to determine the growth rate r. If the problem refers to the continuous growth, then that means r is going to be greater than 0. If the problem refers to continuous decay, then we know that r is going to be less than 0. And then we're going to use the information in the problem to determine the time t. Step 4, we're going to substitute the given information into the continuous growth formula and solve for a of t. So for example 11, it says a person invested $1,000 in an account earning a nominal 10% per year, compounded continuously. How much was in the account at the end of the 1 year? So if you recall from the previous example, in example 10, or the ones before that, we had the compound interest formula. Now, how do you decide which one do you use? Well, if you see the word continuously, compounded continuously, then you're going to have to use this formula that's given. So continuously is an important word to notice when you're going through these questions. Now, how much was in the account at the end of 1 year? Well, since the account is growing in value, this is a continuous compounding problem with growth rate r equal to 0.10 because that is a 10% nominal rate. The initial investment, which was p, is $1,000. And we're going to use the continuous compounding formula to find the value after 1 year. So it's saying in the account after 1 year, so t is going to equal 1. So using the continuous compounding formula, we have a of t, which is equal to p e to the rt. And now we're going to substitute the known values for p, r, and t. So we have 1,000 e, and then 1 times 0.1. So first, evaluate your exponents. So find out what e to the 0.1 power is. So let's go ahead and do that. So on the calculator, we're going to go ahead and write, okay, the value of e, and then we're going to multiply 1 times the rate, which is 0.10, and then select enter, and then we're going to multiply that by 1,000. And that gives us 1,105.17 cents. So the account is worth 1,105.17 cents after 1 year.